Hello friends, and welcome to this session. In this session we are going to learn about the node name, how we can assign a node name during creations of the pod in the specifications file, either in the imperative way using the command or in the declarative way using the specifications for the pod. We are going also look into the node selector, because in this way we can put a constraint on a pod to get it deployed in a particular nodes. So after these sessions we will also going to learn about the node affinity and node anti-affinity, but this particular sessions is specific about the node name and the node selectors. So if you didn't watch my previous video on the Kubernetes, because I have several videos that I uploaded on the subject Kubernetes on all the topics, you can refer my previous video for more understanding on the subject. Okay, so this is the overview where we just highlight what we are going to learn. So we are going to create a pod with the node name and also with the node selectors, okay, in the different specifications file for the pod creations, okay. And we are going to play with the 3 worker nodes, okay, so that we have a clear understanding that what is going on, because if we have a single node cluster, then it will not give you a much understanding on this particular subject. And regarding the tips for this particular things, okay, you can get a direct questions, but not more than the 4%. Okay, the weightage will be 4% because it's very straightforward that you have to deploy in this particular nodes, and you have to use the node name or node selector they will provide you, and or they will not provide you, and they will ask you to get it deployed into a particular node. Okay, so the question will be very straightforward, and they may come or not in the examinations, because this is not a frequently asked, but for understanding, for working in any organizations, this topic is very important. And this topic will not require more than 4% of it is in the CKA certification exam. Okay. So node name and node selector both help to assign a Kubernetes pod to a particular node in a Kubernetes cluster. Okay, so this is the specifications of creating of node, like API version VI, because we are creating the pod metadata, the name of the particular pod we are using the nginx, and the node name we are assigning it to the node 1. Okay, so in the specifications part we are defining the node name. When we define the node name, okay, what will happen when you use the CLI and that particular CLI request come to the Kube API server? Kube API server will just monitor the specifications file, either node name is defined or not. Okay, so in that case, if Kube API server find that the node name is assigned, means then the user want only this pod to be get deployed into this particular node name, then it will not pass this message to the Kube scheduler, because this particular candidate is not suitable for the request that goes to the Kube scheduler. In that case, the Kube's API just provide all the information to the etcd, and etcd is a database, so it keep all the informations regarding the creations of the pod into the etcd. Okay, if you didn't have any informations regarding the etcd, you can refer my video for the etcd, where I discussed about the how to take the backup and how to restore the etcd database in the Kubernetes cluster. Okay, so after saving all the informations for that particular pod, Kube API will contact the kubelet of that particular node. Suppose this is the node 1. Okay, kubelet will instruct API, Kube API server will instruct the kubelet, and kubelet will contact the CRE, either whatever the container runtime engine you have deployed into that particular node. Sorry. So it will provide that informations to the kubelet, and kubelet will contact the CRE, and it will get it deployed into that particular node. Okay, so this is the architecture. Regarding the Kubernetes architecture on all this control, I will provide build a new video, a new session on this, where we discussed about all the component of the master as well as the node. So this will come into the future videos, where we discussed about all these things. For this video, you can just understand that if we assign the node name, okay, then it will not go to the kube scheduler because there is no activity on that particular specifications file at the kube scheduler, because we already defined that on which node we want this pod to be get deployed. Okay, so okay, this is the one thing. If we provide the node name, okay, and then we provide the resources, and the resources is exceeding, okay, the memory of that allocated for that particular node. Suppose this is the node 1 and we have only 2 GB, where we are requesting the nodes the pod to be get deployed with a memory of 21, okay, 2.1 GB, you can understand. So in that case, it will go either in the pending state, okay, or in the out of memory. So you will get a message of out of memory or in the pending state, because at that in that case the kubelet will not able to deploy that particular pod because it's exceeded the memory limit. Okay, so if it doesn't mean that if we have a node 3 which have the 4 GB of RAM, it will get deployed or into that node if it doesn't fit. No, because we already assigned the node 1. This pod will only go to the node 1, not into the other node. Okay, because we didn't pass this task to the kube scheduler, and kube scheduler have the responsibility to just monitor all the nodes to get it deployed into any particular appropriate node. So in this particular case where we are defining the node name, it will go only to that particular node. Okay, either will in the pending or in the successful or on out of memory, but it will not go to get it deployed into the node 2 or node 3. It will not look into that particular node, other nodes, because we already this is the strict condition, you can say, that if I asking a pod to be get deployed into the node 1, it will either get deployed or will be in the pending state or some error will be produced, but it will not look into the other nodes for the deployment. Okay, so regarding the node selector, suppose you have three worker nodes like node 1, node 2, node 3, and we label it accordingly. Like this is we labeled to just this is for the identifications. If you have any confusion regarding the label, you can refer my videos on the label as well. Okay, so we assigned or mark a label for the node 1 as disk is equal to SST. Okay, node 2 disk is equal to SST. So we have two node with the same label, and node 3 is equal to disk is equal to SDT. So we provided the node selector with the we are not providing the node name, but we are providing the node selector. Okay, so these types of request will definitely goes to the kube scheduler. So when you request using the node selector to the API server, it will definitely pass it to the kube scheduler, because we have two nodes that have the same label, and this is the responsibility of the kube scheduler to decide on which particular nodes this pod is going to apply. So kube scheduler decide and give that information to the kube API that I'm going to deploy this pod in this particular node, either node 1 or node 2. When we have a node selector as a disk is equal to SST, because we have two nodes that have label disk is equal to SST. Okay, so in that case, the kube scheduler have the information from the kube API server have the informations from the kube scheduler, and the kube API server will provide that informations to the etcd to save into the database, and then it will instruct if the kube scheduler will decided to get it deployed into node 1, it will contact the kubelet of the node 1, otherwise kubelet of the node 2 to get it deployed, and the kubelet will again contact with the CRE so get it deployed into a particular node. Okay, so let me go to that slide. Okay, so this is the SSD, and it will goes to the kube scheduler, and kube scheduler decides either in the node 1 on the basis of memory allocations, might be node 2 have three nodes, okay, three pods already deployed, and node 1 don't have any pod to get deployed into that particular node. So it will kubectl will definitely pick this one to get it deployed. Okay, so and if we change the disk to the SDT, then it will definitely goes into that particular node 3. Again, the kube scheduler will kube API will pass this information to the kube scheduler, and kube scheduler will decide. In that case, the kube scheduler have only one options to get it deployed into the node 3. And if there is no memory, then it will goes into the pending state, okay, or out of memory error. Any types of exception you can refer by describing that particular nodes why it's not get deployed. So this is the theoretical aspect of node name and the node selector. So we are going jumping into the lab sessions to have a better understanding of this concept, because theoretical aspects have different understanding, and when we do the same thing with the lab, we have a more clear picture. So I'm jumping to the lab session. Okay, so we have a Kubernetes cluster with three nodes, and the two nodes have 2 GB of memory, and the third nodes we have 4 GB of memory. So now going to the Git pass, where we are going to write some command to check the environment. Ctl get node. This is to verify that how many nodes we have. So you can see that the three nodes we have in the cluster. Okay, so kubectl get pod. Do we have any pod? We don't have any pods in this environment. Okay, and this is the file that we are going to use. So I'm going to show you that file. Okay, so this is the node 1 where we are going to deploy a pod using the node name. So we are just going to assign node name as the worker node 1. So if you refer this, we picked this one, CQIOT. Okay, CQIOT to deploy this particular pod, which have the name Nginx node name. Using the image Nginx, we are just going to create a pod in the Kubernetes cluster, and we will see the effect, either it's going to deploy or not. We didn't provide the resource limit, means it goes into the default with the default resources, the memory and its limit. So I'm going to just get it deployed into the Kubernetes cluster. kubectl apply using the file name NodeName dot YAML. Okay, it get created. kubectl get node. Okay, let's clear the screen. kubectl get pod of white. This give you extra information, so you can find that pod that gets deployed into the worker node 1, because we provided the node name here. Okay, and so it will not go to the API. Kube API will take the decision, and it not provide the informations from the kube scheduler. Okay, because this is the strict conditions. Okay, now I'm going to, there is no need to delete, because we already have different name for the resources. In these particular things, we have the exactly all the things same as still. Okay, so we just provided the resource, and we requested that the memories to be uh, more than the node memory. Okay, so we will first describe the node 1. Okay, in the cluster I already show you the node name is of 2 GB memory allocations it have, but for better understanding, I'm going to describe the node 1. kubectl get node. Okay, now I'm going to copy it. kubectl describe node, and just providing the node name. Okay, here you can find at the top that how many actually memory it's for this node particular have. Okay, so you can find that in the CPU. Okay, so this much memory is available, means this is to utilize. Okay, so you can refer it here that and I'm providing 2.1 GB, so it will definitely going to fail. Now I'm going to clear the screen. So I want this pod to be get deployed into the worker node 1 with this particular name. But the memory that I'm asking for this particular pod to get deployed into the node is exceeding the node limit. Okay, so what I'm going to do, let's write ls kubectl apply -f node name resource.yaml. Okay, so it will deploy this into the node 1. Okay, get pod. So you can see that we are asking for the higher a pod with the higher memory to get deployed into that node, and we are getting the out of memory. Okay, so if we allocate this pod to get deployed into the node 2, we will have the same error because the node 2 also have the 2 GB of memory. And now I'm going to deploy it in the worker node 3. So for this I have to change it. Let me take the name of that kubectl get node. I'm going to use the third one, copy, and I'm going to use it here. Just paste it, save it, and now I'm going to use the same command. Okay, why it's saying, because it's getting deployed into the same environment and we don't have a similar pod name exist. Okay, so we have to change it or we have to delete it. So let's say we are not going to change it, we are going to rename it with a different name of the pod. Okay, so I'm going to save it with the one I say, and now I'm going to run it again. So it's get created. Now I'm going to clear the screen. kubectl get pod or right. Okay, so this is our pod, and it's get deployed into the worker node 3, and it's in the running state. And this one was the previous one which we are asking to get it deployed into the node 1, and it's failed because of the memory issues. Okay, so this is related with node name. Okay, so now I'm going to clear the screen, and now we are going to look into the other things like node selector. Okay, so for this we have to assign some label on 3 nodes. So this is equal to, we can use the SST. Okay, so let me copy it, and here I'm going to use it for the each node, kubectl get node. Okay, and here we are going to add the label kubectl label node, and this is the node. Okay, we are going to copy it, pasting it here. Label, what is the disk is equal to SSD. So it added the label successfully. Now I'm going to use the same label for the 2 also. Okay, in the same way for the third also, but here SSD. Okay, all the 3 nodes get labeled, and let me verify it. kubectl get node So labels. Okay, so by default, Kubernetes also add some labels on the node. So you will find somewhere here. Okay, so for the node worker node 1, we have disk is equal to SSD, and disk is equal to SSD for the node 2 as well, and disk is equal to SSD for the third worker node. Okay. Now what we are going to do here, let me open the Visual Studio Code, and we are going to assign with this particular node pod name, and we are selecting the node selected. We are using this is equal to SSD. Okay, so we have two nodes that have the label SSD, and it will get allocated to one of them. Okay, on the basis of the decision make by the Q API scheduler. Okay, dot YAML. Okay, Qs. So you can see that this one, the node name and the node selector. Okay, so it will get deployed into the node one because it also have the SSD level, and it's based upon the decision taken by the cube scheduler. Either it will go into the node 1 or node 2. So I will do one more thing. So either we will delete it or rename this particular pod because the same name not of the pod not exist second time, so it will throw an exceptions. So I am going to put it as 1, but this time we are using adjust, so it will get deployed. What will is the name of the what is the label that we assigned? Let me check it again. So labels, and it have HST. Okay, so we have to do it similar way, HST. Okay, now I'm going to save it, and we have the node selector 1. So it will create a new pod with this name. Okay, there is no conflict with the naming this time. So I'm going to apply the same specification file again. This time this will get deployed into the node 3 because this have the level of HST. QCTL, we get node, we get pod of what? So node selected 1. Okay, this is the name, and it's get deployed into the node 3. So that's it for guys in this particular sessions. And if you like my video, please subscribe to my channel, gives me a thumbs up, and put some comment if you have any confusion on any of the session, or if you want to get any error, you can ask me, and I will definitely respond on your questions. And please share this channel links with your friends as well. Okay, and keep subscribing, keep liking my video. This will motivate me. Thank you for watching this video. Have a nice day.